Chinese skyscrapers have holes through the middle, and the reason why will change the way you see every skyline on Earth. In cities where a single square foot of commercial floor space sells for more than most people earn in a month, developers are voluntarily destroying thousands of those square feet punching voids through their most valuable buildings on purpose. We're talking about a 48-meter hole through the center of a circular tower that's taller than the Statue of Liberty from base to torch. You heard that right, a hole bigger than the Statue of Liberty, cut straight through a skyscraper, on purpose, at a cost of tens of millions of dollars. What makes a developer do that, and how does a building survive it? The answer starts in Shanghai, 492 meters above the ground. Shanghai World Financial Centre. Imagine you are standing at the base of a building, so tall that the top of it disappears into low cloud. You crane your neck back, and somewhere near the peak 492 meters above the street, there is a hole. Not a window, not a gap between floors, a void. A deliberate, engineered absence punched through the top of one of the tallest buildings on Earth. That hole almost started a diplomatic incident. When the Shanghai World Financial Centre was first designed in the 1990s, the opening near the top was a perfect circle. The engineering logic was sound. At super tall heights, wind is not background noise. It is a structural force that determines how much steel goes into a building and, by extension, how much the building costs. A circular opening at the top of the tower would allow wind to pass through rather than push against a solid face, reducing the lateral load the structure has to resist. Less lateral load means less steel. Less steel means hundreds of millions of dollars saved. The hole was not a design flourish. It was a financial calculation. But then locals looked at it, and what they saw was not an aerodynamic solution. What they saw was the rising sun, the circular emblem of Imperial Japan, on a Japanese-funded skyscraper, rising over the Pudong skyline. The protest was immediate, and it was not quiet. Here is where most buildings would have compromised the engineering to fix the politics. The designers did something more elegant. They changed the shape of the hole. The circle became a trapezoid wider at the top, narrowing toward the base, and in a single redesign, the building stopped resembling the Japanese flag, the cultural objection evaporated, and the aerodynamic function was preserved. One change. Two problems solved simultaneously. The structural system holding that void together is a mega-frame of diagonal steel bracing, running the full height of the tower, a lattice of members that routes structural forces around the absence rather than through it. Think of it as building a bridge around a hole rather than over it. The forces that would normally travel straight down through solid structure are intercepted, redirected around the void, and reintroduced into the building below. The trapezoid hangs in the skyline not despite the engineering, but because of it. And here is the thing that should stop you cold. The void that nearly caused an international incident that was redesigned under public pressure, that satisfies a cultural sensitivity and solves a wind load problem at the same time that void saves so much structural steel that it changes the economics of the entire building. In Shanghai, the absence of material can be worth more than the material itself. That is the pattern, and once you see it, you will see it everywhere. Guangzhou Circle. But the Shanghai World Financial Centre is still a tower with a hole near the top. What comes next is something categorically different, a building that is not a tower with a hole through it, but essentially a hole with a building built around it. You are standing on the northern bank of the Pearl River in Guangzhou, and rising in front of you is a perfect ring. A complete, unbroken, 138-meter circle of occupied floor space with a 48-meter void at its center. Climbing into the sky like a giant coin stood on its edge. That void is taller than a 15-story building. You heard that right. The empty space at the center of the Guangzhou Circle could swallow 15 conventional floors whole. The cultural logic starts with jade. Bi-discs, circular ritual objects with holes at their centers, have existed in Chinese culture for over 3,000 years, representing heaven, completeness, and cosmic prosperity. The number 8 is the luckiest number in Chinese numerology. The Guangzhou Circle was positioned on its specific Pearl River plot so that its silhouette, reflected in the water at the right time of day, completes the shape of the number 8, positioned it like a sundial, calibrated to a river, to make luck visible from the street. Now, here is where the engineering becomes something that should genuinely unsettle you. In a conventional skyscraper, loads travel downward in clean vertical paths. In a ring, those loads have to travel through a curve, which means every structural element is simultaneously being compressed on one side and pulled apart in tension on the other, with those forces shifting continuously at every point around the ring. No existing high-rise structural model was designed to handle this. The solution was a diagrid exoskeleton, a lattice of diagonal steel members wrapping the exterior, triangulating the curve so forces distribute across dozens of paths rather than collapsing inward. The luck is real. It just required entirely new mathematics to arrange it. But if you think a ring is complicated, wait until you see what happens when two towers try to hold hands 300 meters above the ground. Gate of the East. Two towers, 302 meters tall each, rising side by side from the city of Huzhou, close enough that you could imagine reaching between them and then, at the very top, connecting. A 9-story skybridge spanning the gap, turning two independent skyscrapers into a single continuous arch visible from miles away. Locals took one look at it and called it the Trousers. The name stuck instantly, spread across the internet, and became completely inescapable. The developers did not appreciate it. The architects did not endorse it. And yet here we are, because when you squint at the Gate of the East from the right angle on a hazy Huzhou morning, the nickname is, unfortunately, perfect. 2 legs, 1 waistband. Done. But here is what the joke obscures. The thing that looks ridiculous from a distance is, from a structural engineering standpoint, one of the most demanding problems in this entire story, and the solution required engineers to design a system that has almost no precedent in residential construction anywhere on Earth. Here is the problem. 2 towers, each carrying their own gravity, loads the accumulated weight of 300 meters of concrete, steel, glass, and the people living inside, traveling downward through their own independent structural systems to their own foundations. That is a solved problem. Engineers have been doing that for a century. But now you are asking those 2 towers to physically connect at the top, 250 meters above the ground, through a bridging structure that weighs thousands of tons and spans empty air. That bridge cannot simply rest on top of the towers like a book on 2 stacks. It has to connect into the towers structurally, transfer its own load into them. And this is the part that keeps engineers awake. Allow both towers to move independently of each other under wind and seismic forces without the connection point tearing itself apart. Because towers move. Under wind load, a 300-meter tower sways. Not dramatically, not in a way you would notice standing in the lobby, but measurably, continuously, in response to every gust. 2 towers standing side by side do not sway in perfect synchrony. They move at slightly different times, in slightly different directions, by slightly different amounts. If your sky bridge is rigidly welded to both of them, those differences in movement create forces at the connection points that the structure was not designed to handle. And it is not just wind that pulls them apart. Over decades, both towers are going to sink into the ground at slightly different rates. Every foundation settles the question is never whether, but how much. If one tower sinks 3 millimeters more than the other over 20 years, and the sky bridge connecting them is rigid, that 3 millimeter difference translates into a permanent structural force at the connection point that accumulates year after year with nobody coming back to fix it. The solution was an outrigger transfer system, horizontal outrigger arms extending from the reinforced concrete cores of both towers into the sky bridge structure, effectively turning the cores themselves into the columns of the arch. The outriggers do several things at once. They stiffen each tower against lateral movement by connecting the core to the perimeter. They carry the weight of the bridge and distribute that load into the core below. And they are designed with enough engineered flexibility at the connection points to absorb both the wind-driven differential sway and the long-term differential settlement without transmitting destructive forces across the faces. bridge. Every millimeter of movement those towers will ever make has already been accounted for in steel that knows how to give just enough without giving way. The arch shape references the traditional Chinese city gate, a form that has carried cultural weight for centuries as a symbol of entry, protection, and the threshold between outside and inside, between the ordinary and the significant. The developers wanted a building that read as a gate that announced arrival, and then they handed that brief to structural engineers and said, "Make it stand." The engineers made it stand, and the city gave it a better name. The next building took everything that makes the Gate of the East complicated and multiplied it by an order of magnitude, because the next building does not just lean toward another tower, it is the other tower. Both of them, at the same time. CCTV Headquarters. Everything covered so far has been a building with a hole, a tower missing a piece, a ring around an absence, two towers bridged at the top. Complicated, yes. Unprecedented, sometimes. But in every case, you can still point to the ground and trace a more or less vertical line from foundation to roof. The CCTV headquarters in Beijing does not give you that line. It does not give you anything vertical to hold on to at all. What you are looking at, and the first time you see it, your brain will genuinely resist processing it as a building is a continuous structural loop. Two towers rising from a shared base, both leaning toward each other at 6 degrees from vertical, climbing 234 meters into the Beijing sky while tilting visibly, decisively, at an angle that every instinct you have about architecture tells you is wrong. And then, near the top, instead of stopping, they reach across to each other and connect through a massive L-shaped cantilever that extends 75 meters beyond the base of either tower, completing a bent tube of occupied floor space that has no beginning and no end. 6 degrees from vertical does not sound like much, but stand in front of this building and you will feel it in your stomach. The overhang is not subtle. It is not a slight lean you might attribute to a camera angle. It is a building that is, demonstrably, doing something buildings are not supposed to do, and doing it with complete structural confidence. But the lean is not even the hard part. The hard part is what happens to the forces inside it. In every skyscraper ever built before the CCTV headquarters, structural engineers worked from a foundational assumption so basic that it was barely worth stating out loud. Gravity loads travel downward. Loads accumulate floor by floor, column by column, traveling in roughly vertical paths from the roof to the foundation. Every structural model, every calculation method, every piece of software used to design tall buildings was built on that assumption. In the CCTV headquarters, it is not true. The loads travel through a loop. They travel down through leaning towers, across through a horizontal cantilever, up through the overhang, and back again. You are looking at a building where gravity does not get to travel in a straight line, and every single point in the structure has to handle forces arriving from directions that no conventional skyscraper would ever ask it to. The building does not just resist unusual forces, it lives inside them. The engineers at Arup, the same firm behind some of the most structurally ambitious buildings of the last 50 years, had to develop entirely new load path calculations, not adapt existing ones. Not apply existing models to a new geometry, develop new ones from first principles, because no standard structural model could predict how forces would move through a building shaped like a bent tube. The mathematics required to design the CCTV headquarters did not fully exist when the project began. The engineers had to invent the tools alongside the building itself. Now look at the exterior of the building. Look carefully at the pattern on the facade, the lattice of diagonal steel members covering every surface. Notice that the pattern is not uniform. The density of the diagonals changes as you move across the building. In some areas, the lattice is open, the diagonals widely spaced. In other areas, it tightens, the members clustering together, overlapping, thickening. That variation is not decorative. It is a direct readout of the structural stress analysis. The diagrid is densest, where the forces are highest, and most open where the structure is under the least demand. You are looking at a building that is wearing its own engineering on its skin, a map of internal forces made visible in steel and glass. And then there is the construction sequence, which is its own kind of nightmare. The two leaning towers had to be built simultaneously, rising in parallel, because neither one is a stable structure on its own. A tower leaning at 6 degrees from vertical without a counterbalancing structure on the other side is an incomplete loop under eccentric loading. It wants to fall in the direction it is leaning. During construction, before the cantilever connected the two towers at the top, engineers had to calculate the stress state of each tower at every single stage of construction, accounting for the fact that the structure was incomplete and the loads were not yet balanced. Every pour of concrete, every piece of steel erected changed the stress state of everything already built, and the engineers had to track that in real time. One miscalculation, and an unfinished tower leaning into empty air has nothing to catch it. The moment the cantilever connected and the loop closed, the building became a fundamentally different structural organism. Forces that had been building up in the incomplete towers redistributed through the completed loop. The building settled into its final structural state, and the mathematics that had predicted that state, the new mathematics developed specifically for this building, turned out to be correct. The loop held. The lean stayed, and the building that had no right to stand was suddenly the most structurally audacious thing ever built. The CCTV Headquarters has no feng shui justification. There is no dragon mythology, no lucky number reflected in a river, no cultural gate symbolism. Its hole, the void at the center of the loop, exists because a client wanted a form that was architecturally unprecedented, and the engineering followed the ambition rather than the other way around. That is what ambition costs when you refuse to let physics have the final word. But even the most structurally ambitious building on Earth still only has to answer to itself. The next buildings have to answer to an entire harbor and to thousands of residents who will never know what is holding them up. The Arch and Larvado. Hong Kong does not do anything quietly. So when the arch rises from West Kowloon with 4 towers arranged so that 2 of them meet 231 meters above the ground, forming a giant arch over the harbor, it does not feel like an accident. It feels like a statement. But the engineering underneath that statement should stop you cold. 2 full towers with every kilogram of concrete, every floor of glass, every live load of every resident inside them are converging at a single junction point, 231 meters in the air. That point has to collect the structural forces of both towers simultaneously. Wind-induced sway arriving from 2 different directions, seismic forces. The dead weight of 2 complete residential towers connected to the same node, all of it landing in one place, all at once, all the time. The transfer truss system at the junction is essentially a structural switchboard, a deep multi-story truss that intercepts forces arriving from multiple directions and redistributes them into the arch structure below, which then carries the combined load back to the ground. It is one of the most force-dense connection points in any residential building ever constructed in Hong Kong. You walk past it in the lobby and it looks like architecture. It is in fact a solution to a problem that would have been considered unbuildable 20 years earlier. Then there is Larvado, and this one will reframe everything you think you know about Sky Gardens. The holes in the Larvado residential cluster in Hong Kong look like luxury amenities. Open sky gardens punched between buildings, framed in greenery, photographed endlessly for property brochures. What the brochures do not tell you is that those gaps were justified to the developer through computational fluid dynamics, modeling the same software used to design aircraft wings, which proved that the voids reduce internal wind pressure across the cluster by measurable percentages and increase natural airflow through the residential floors enough to eliminate the need for mechanical ventilation on multiple levels. The Sky Garden is not a feng shui gesture. It is a ventilation shaft. It passed an aerodynamic simulation before it passed a design review. The hole that looks like a luxury is doing an engineering job, and the residents paying a premium to live beside it have no idea. But not every hole needs a city around it. Sometimes, a hole just needs a lake. Sheraton Huzhou Hot Spring Resort. Every building so far has fought gravity, wind, and physics inside a city grid. The Sheraton Huzhou Hot Spring Resort removes all of those constraints and asks a simpler, stranger question: What if the hole was made of water? Rising from a lake in Huzhou, it is a horseshoe-shaped tower that appears, from almost every angle, to complete a perfect circle with its own reflection. There is no void punched through steel and concrete. The lake is the hole. The building wraps around water rather than around air, and the circle only exists because the reflection completes it. But here is the problem no one talks about. A horseshoe is one of the worst shapes you can ask a structure to hold. Every floor plate is a different shape from the one below it, because no two levels sit at the same point on the curve. The foundation engineering demanded piles driven at angles a conventional vertical tower never requires. Fighting a lakebed that wants to push back in directions the structure was never meant to move. And because the building curves rather than rises straight, the loads do not stack neatly, they migrate, shifting their path through the structure at every story. The engineers were not designing one building. They were designing dozens of slightly different buildings and forcing them to behave as one. This is the cultural logic taken to its most poetic extreme, the bidisc, the circle of heaven. The symbol of completeness, realized not through a diagrid exoskeleton or a transfer beam, but through the still surface of a lake at the right time of morning. This is what the philosophy looks like when it escapes the city entirely. What remains is pure symbol, a ring that only exists in reflection, and a building that needed a lake to feel complete. The Repulse Bay. But the building that started all of this is not a super tall in Shanghai or a ring above a river. It is a luxury residential complex on the southern shore of Hong Kong Island. And punched through its middle, aligned perfectly with the ridge of the hills behind and the water of the bay in front, is a rectangular void wide enough to fly a helicopter through. Locals will tell you the hole is there to let the dragon through. In Chinese tradition, dragons are not monsters. They are forces of prosperity, cosmic order, and power. And the hills behind Hong Kong are understood to be their home. A building that blocks the dragon's path from the mountain to the sea invites misfortune on everyone inside it. The Repulse Bay hole exists so the dragon can pass unobstructed. But here is the engineering truth the mythology sits on top of. 12 floors of residential apartments are spanning that void, and they are not holding themselves up. A transfer beam several floors deep spans the full width of the opening at its top, invisible to every resident above it and every visitor standing below it, quietly carrying the weight of everything the mythology says the dragon is passing through. And here is the detail that ties every building in this story together. The hole made the remaining floor plates worth more. The view corridor it created increased the desirability of every apartment with line of sight through it. The developer sacrificed floor space, and the floor space that remained became more valuable because of the sacrifice. The dragon, it turns out, is extraordinarily good for business. And the skylines full of rings, arches, loops, and dragon gates are simply what that truth looks like when you build it 120 meters into the sky.